Good morning, Game Docs. Chris again. Just wanted to show you the latest project. This is what I'm calling SyncSec. It is a security camera that I made for my house, and it uses BitTorrent sync to transfer the files to other machines. Real easy project. The longest part was designing the 3D printed case. It's actually 2 pieces. And yeah, just want to show you that real quick, an overview of the parts that it uses. So we shrink my face down a little bit. So I'm using an original Raspberry Pi Model B. That's just because I had a couple extra laying around. Might as well use them, right? I honestly think the B Plus would do a better job. I've just noticed that the B Plus is much more stable when you're doing almost anything with it. In fact, for the BitTorrent sync, I have a B Plus that I'm using as a syncing node, just so that when my desktop and my laptop both aren't online, well, I've got that little guy there, so that if anything happens to the camera, I still have the pictures that it took. So I'm using that. I used a lot of these to hook up components just because I didn't want to permanently solder to the board. Now these are permanently, like I'd cut off one end and I permanently solder it to the switch or the LEDs or the passive infrared sensor. The lens that you saw is actually one of these little guys, the TOC TM Universal 180. It's made for, as you can see, iPhones. It's got a magnetic ring to attach to the back of the iPhone, but I just made the hole that it goes in just big enough. It's real snug in there. It's not even glued in. For the wireless adapter, I'm using one of these. I've noticed that if you use the Wi-Fi adapter, it's quite a bit larger, but it seems to get a better connection, but this is working fine. And then this is the passive infrared sensor that I'm using. I just went down to my local Radio Shack, picked it up, and this exact paddle switch. It all works pretty well. A lot of the information I got for getting BitTorrent sync to work correctly comes from this jackminardi.org website. I'll put a link in the description to this page. Some of the information is old. So yeah, let's go ahead and cut to wiring it and programming it. Alright, so I can't crack open the actual unit that I made. It's being held closed by hot glue, like all high quality electronics. So this is an old Raspberry Pi that's dead, and as you can see on the screen below, I have the pinout from elinux.org. So it's all really simple. Forgive all the ums, guys. This is the passive infrared sensor. It's got 3 pins, and one of the things I really like about this Radio Shack sensor, even though for the most part I don't like Radio Shack, is it can take 3 or 5 volts. Now you see from this orange line here, I have it hooked up to the 3-volt power. Just because the more power you draw off the Raspberry Pi, the more problems you can have. Now its 3 pins are VCC, which is power in, ground, and just out, which is where it sends the signal when it detects motion. Another thing I like about it is it has 2 different trigger modes. So if I pull this off, on the front here, this black jumper, I can go between N-trig and R-trig, which the difference between that is one will trigger for 4 seconds. Any motion it senses, it's triggered for 4 seconds. The other is a continuous signal. So as long as it's sensing motion, it goes. It just sends a high signal. I like that a lot. Something else that I haven't played with yet, but on the back you have a place where you can mount variable resistors, and it's not gonna let you see it clearly, but right here at the bottom you can kind of see them here. Yeah, those gold contacts, not gold, but gold colored contacts. Those are where you can put variable resistors, so you can change its distance and delay. I haven't played with that because I haven't needed to, but it's real neat, I think. I have, like I said, the orange line is the 3-volt power. This gray line is going to one of the ground pins, One of the great things about ground pins is you can tie them all together on one. I didn't because I had enough ground pins that I didn't need to. And it doesn't matter which ground pin you go to. And I have the brown going to GPI 17. So that works out real nicely. Real quick. The blue and red are for the LEDs. I don't have any LEDs set up right now. One of the things to note, and I'll show you later, is that the two LEDs that I have, they're both infrared, but they're not enough light to do well in super low light conditions. Like at night when we're asleep, you don't see a whole lot with just two. Now you can try to add more, but the power draw on the Raspberry Pi would be high enough that you risk the Raspberry Pi resetting or failing to power on whenever you do that. So what I've done is I've gone on Amazon and I've ordered it's a professionally made pack of infrared LEDs that you just plug into a wall wart and it'll illuminate with infrared light whatever room you're in. Now obviously there are ways that you could engineer around that. I'm not a professional engineer, I'm a bad hobbyist. But I've got them tied to pin 21. Wow, I sound real good at this. Yeah, pin 21. On the revision 2 boards, it's pin 27. Whichever one you're using, go with that number. But the nice thing about the Raspberry Pi is when you have a pin set up as an output, whenever it goes high, it's sending out 3.3 volts. So since every LED is different, especially when it comes to infrared, I used this LED wizard, and I got my LEDs off Adafruit. One of the things I like about Adafruit is when you buy components from them, they tell you almost all of the technical specifications. So you can put in your source voltage, which for this was 3 volts, your diode forward voltage, which for these ones was 1.8. Its forward current, which is how much current it uses, and those two LEDs that I'm using use pretty much all the current you can, and the number of LEDs in your array, and it'll tell you what kind of resistors you need to use. For these, it ended up being a single 1 ohm resistor, and then these two I have set up for the switch, this white and purple. Now I have it tied to the next GPIO pin down, and I have it set up as a, I lost my mouse. I have it set up as an input, so that's pin 22, and it's just a switch. So if we go over and show the programming here, the subprocess import call, that's not necessary. I thought I was going to be doing some other stuff, but you can see here is my GPIO setup. Let me make that bigger. So that's my GPIO setup. I have it using BCM mode. You can also do board mode. It's two different numbering systems, and the board numbering system changes with each revision to the board. So BCM kind of makes your projects a little more revision proof. So you can see here I have 17 set up as an in. That's for the passive infrared sensor. 21 for the LEDs is an out. 22 is another in. That's for the paddle switch. And this is Python, by the way. I forgot to mention that. I was playing around with flipping the image. Instead, I just rotated it 270 degrees. I have it saving an EXIF tag for the artist information as TweetSec Living Room. That was the original name of this project. And then this is your resolution. A quick Google search can show you all the resolutions supported by the Raspberry Pi camera module. I went with this because it's large enough to see most details, but it's small enough that I can let it run and take thousands of pictures before I have to worry about the Raspberry Pi storage filling up. I just have to do a try. There's no main in here because this was originally just a test script, but it works well enough that I feel comfortable running it. So I have it set up so that if pin 17 is high, infrared sensor, and pin 22, paddle switch, is low, that's when it turns on the LEDs, so that's pin 21, and then it uses the date time library to save that information to a local variable. Then current time is a string, ends up being a string variable that takes the information from right now and saves it to a string. So then I can say another string variable file name is this, so it ends up being capture-currenttime.jpg, and this pictures here is because the script isn't running in the same folder where it's saving the pictures. You have to include the folder that it's going into. And then I have it camera.annotate text. This is a really neat feature that I like a lot, where like we take a look at this picture of my wife leaving super early in the morning. Thank you, sweetheart. Up here there is that same variable information of what time the picture was taken. So it ends up being coded into the picture itself. I like that feature a lot. Let me get back to the recording window. And then you just call camera.capture, and it wants a string variable in there. You can type your own in, but with this it means every second it takes a picture, it's a different file. And this was like if you have it running off of a SSH terminal or hooked into a monitor, it'll tell you when motion is detected and at what time and all that. Now, if neither of these are true, it doesn't take a picture and it turns the LEDs off. And then I have it set up so that you can quit from keyboard, and it closes the camera, cleans up the GPIO. If you do a regular shutdown, the Raspberry Pi should take care of that itself, but that's just for safety. So, I am actually SSH'd in. Whoops. And can I? No. Here we go. So I just wanted to make it legible for you guys. I'm SSH'd in. Now, in order to get BitSync up and running, BitTorrent sync, this guy here, Jack Minardi, has a great write-up. It's a little old, but like 98% of the information is still good. So he has you go through and make a folder for BitTorrent sync, and then use the wget command. Now I will say this, do not use this link he has here. It's an old version. It'll still kind of work, but it's an old version. In order to get the correct link, go to getsync.com, go to their download, and under the Linux versions, you want to use ARM, since that's the type of process the Raspberry Pi uses. Hit cancel, and then where you see click here, you can just do copy link address. And I've already done that here. So you can see here is the link address, and you just, when you're in the folder that you made, you just do wget and that. It downloads it, and then this part still works fine. The untarring it. Just replace this with whatever the file that was downloaded is. And this information right here is great if you want to mount a USB drive for your storage. I can understand why a lot of people would do that. You want 32 gigs, you know, or whatever. Now then, in order to start it, you go into the folder and you say sudo./bitsync. You have to run it as a super user, and it'll fork into the background. Now, the Raspberry Pi is great at a lot of things. It is terrible, absolutely terrible, at browsing the web. So instead of just running it, my suggestion is you run it with this afterwards. So you type in the sudo./bitsync, and then you put in this here. What this does is it'll open it up so that any computer on your network can go to the Raspberry Pi's IP address and open it up. If you tried to do it on the Raspberry Pi, hooked to a monitor, keyboard, and mouse, I had it take 3 hours to load the page that it was serving. So if we actually go here, I have my little node set up, and I believe it's 23. Yeah, so it's 23:48, and then this lets you access it and run it that way. You can use a configuration file, which I'll show in a little bit, in order to keep it all up. But yeah, as you can see, this is it running. This is the TweetSec backup, and it can see the camera and it can see my desktop that I'm recording this on. So it's real nice, real handy. For the configuration, if you want to use a configuration file for it, which is nice because if something happens and BitSync no longer sees what you're trying to do, like it loses its information. Excuse shaky cam there. If it loses the information, then you have to start all over again. The configuration file will prevent that. Now, in order to do the configuration file, you're going to want to type in this here. Alright? And that'll dump a sample configuration file that you can then edit using Nano or V or whatever you want to use. And I actually have an example of that here. So it's just called btsync.conf. Right? And you can change your device name, your listening ports, whatever you want to do. And what I did in mine, and it's kind of funny, if you end up using the shared folders information, it automatically disables the web UI. You can't have a web UI if you do this. You're going to need a secret, which is just the key that it uses. So if we actually go here and we go, I'm already in the folder as you can see, and we go /, oh, that's not a dot. Did I forget something? Let me go --, generate secret. That right there that it generates, you can use that. It's a read-write key and all that. So when you do that, you put it in here where I have all these asterisks, and then you set up the directory that you want it to use, and you can tell it if you want to use relay servers, trackers, DHT, all that. I turned off the use sync trash. What that is, it's an archive of things that get deleted by either the main host, the one that generated the key, or anybody connected. So if you do that, you know, like I understand why you'd want to have an archive. I didn't want one because, you know, I check this camera every day and I just delete things. You know, hopefully nothing ever has to happen that I have to keep a photo. But yeah, that's the basic setup of it. And then in order to make it all run, I made a launcher script. So if we go nano launcher, this is just, you know, you can run the launcher, blah blah blah, have it go to the home directory, then I have it go to the btsync, then I have it run btsync, and then this --config tells it, hey, run with the configuration file that I'm giving you here, right? And then I have it go to the folder where my Python script is, and then I have it run the Python script as sudo. A lot of the camera stuff won't work if you're not sudo. I'm not sure why that is, but so once you have that set up, and I have it saved in the home directory so it's easy to find, then you can edit your cron tab, and that's just sudo cron tab -e, and then here I have it commented out so I can do this video, but I just say at reboot, use the shell command, and run this location with this file. So whenever it reboots, it already starts up btsync and it kicks off the Python script. So I'll go ahead and do that, save the changes, and that way when this reboots it automatically goes into it. So that's all the information really. It's real simple. If you guys are interested, let me know. I'll show you the 3D files that I made up for the case. I just didn't want to use a regular case because it ends up looking all junky in my opinion. Since I have a 3D printer, I designed and printed one. That was honestly the longest part of this project because I just started designing things in 3D like a week ago. Oh, probably 2 weeks ago. So it was a pretty big undertaking getting everything to fit right. I got my little digital calipers so I can measure where things are, and it worked out, I think, pretty well. Although 3 weeks is a long time to design a simple Raspberry Pi case, but I wanted everything to fit real tight, real well. So let me go ahead and show you guys some of the pictures that it takes. So this one that you saw before, that's my wife leaving for work real early in the morning. I love her dearly for it. Let me go ahead and make myself smaller. Don't have that big of an ego. But yeah, so there it is. And this one is an example of the best you can expect with 2 infrared LEDs. If I were to do the project again, it would need a bigger case, obviously, for this plan, but I would design it so that it could have probably at least 10 LEDs running off of a separate power source so that it didn't drain the Raspberry Pi. But overall, I'm real happy with how this has worked out, and I hope this helps you guys. Over and out, Watcher 6. If you're interested, stay tuned for a time lapse of printing the top of the case. Peace!